All right, let's talk conics, guys. In 5, 4, 3, 2, 1. All right, so the first thing I'm going to do here, let's grab everything and bring it down a little bit, is talk about the center. If I'm trying to give you just a straight center, we would talk about it like this. And some of you might have seen this. H is my horizontal shift or translation, and my vertical shift is my K. Right? That's my center from the origin of 0, 0. All right, so with the parabola would look like this. First of all, it's got LLR. Tells me how wide it is. And that's accompanied with my y value, usually, unless it's going to be a horizontal parabola, then it would be x here. So this would be the shift on the y-axis equals x minus the shift on the x-axis squared. I'm going to write them all down, and then I'm going to give you guys time to write them down. My circle is that same x minus h plus y minus k. These are both squared. Only I have a radius squared underneath them. Or you could put the radius on this side if you choose. Now let's look at ellipse. So the ellipse also has the exact same horizontal and vertical shifts that we talk about. So x minus h squared plus y minus k squared. Only they're not both r squared. They're different, right? Because if they're the same, they'd be a circle. So not for any particular reason, but we're just going to call them one a squared and one b squared because they're different, right? Their values are different. If they were both a squared, it would be a circle, right? And the last one's my hyperbola, and the only difference between that one, we'll do it right here. X minus h squared, y minus k squared equals 1. Also, they don't have to be different though, right? They could both be a squared. Sometimes they're different, sometimes they're not, but the only change here is this is minus. So all of them are the same, right? All of them talk about a horizontal shift or a vertical shift, and then this one just happens to talk about how wide it is. This one happens to talk about how wide it is on the x and how wide it is on the y, how wide it is on the x, how wide it is on the y, how wide it is on the x, how wide it is on the y. It's all the same thing, right? Only this one only has one width, and the others have 2 different widths, right? Okay, so if you want to write that down, go ahead. I'm going to give some of you a few minutes to do that. All right, I want you to look at these 2 things for a second and compare and contrast them. They have similarities, they have differences. And can you guys just talk in your groups for like 1 minute about what those similarities and differences are? You know, it dawned on me that this isn't very clear. This is the branch right here. Okay, just making sure. Okay, do I have any takers? They have the same center. Yes, good. What else? One's adding and one's subtracting. That's what makes one of them an ellipse and one of them a hyperbola. Allison? The x and y are switched. That's true. But notice that the orientation is the same. This one is a vertical orientation, and this one's also a vertical orientation, yet those are switched. So what's the difference between the 2 of these? Yes, Sarah? The signs are different, yes. That does change everything. I guess the point I'm trying to make with this is what makes an ellipse have a vertical orientation is the fact that the y is bigger. So this one, I'm going to be going out to and out to, out to and out to, and this one I'm going to be going up 4 and down 4, and that's what gives it that shape, that orientation. But with the hyperbola, that's not the case, right? Because even though you're still only going up 2 and down 2 on the y, and you're going out 4 and out 4, even though you're going out further, it doesn't matter which one's bigger. What matters is which one comes first. Since the y comes first, it's going to be, the orientation is going to be on the y-axis. And so I just want to point that out, because some students will look at these these numbers and go, oh, this number's bigger, so it's going to be an orientation going up and down. Then they'll look at this one and go, oh, this number's bigger, so it's going to be an orientation of going up and down. That's not the case. What makes this one have an orientation of going up and down is y is in charge, right, instead of x. So I just want to make that distinction. Questions? Okay. All right, we're going to do a scavenger hunt now. So I want you to be able to use the notes you just took, or I can put them back up here. All right? And you guys are going to go around, and you're going to identify some graphs for me. I'm going to pause the video. All right, good job, guys. All right, next. Remember this graphic? Yeah. Okay. Are x and y both squared? If they are, we go down to the next one. If they aren't, we know it's a parabola. And I'm just going to do a really basic one. It would be an LLR. And this would be a vertical parabola. We'd have a y equals x squared. That's one centered at the origin. Right? I'm going to write all these centered at the origin, just so you can see them. All right, so what if it does? If they're both squared, then we ask ourselves, do x squared and y squared have the same sign? Because if they don't, then we have a hyperbola. In this one, y is squared. Y is negative, x is positive. We don't really know what these numbers are, right? And that doesn't matter. They're both different, or they could be the same, doesn't matter. But what really matters is that there's a negative sign right there. So what if they both have the same sign? The next question I'd ask myself is, do they have the same coefficient? If they do, it's a circle. If they don't, it's an ellipse. So if I have an x squared and a y squared are both positive, right? But they have different bases or denominators, then we're going to say it's an ellipse. But if these two numbers are the same, then it would be a circle. I'm going to write it just like the other conics. I could put the r squared over here, but I'm not. I'm going to put the r squared underneath. Okay? So we're going to use that on each one of these that we're going to do today. You guys already have this in your notes. Yeah, you should already have that in your notes. Okay, this is what's coming next. I just thought I would show it to you. This is two conics, right? It's called a system of equations. So you can solve for a system of equations with conics, which is where we're going tomorrow. So the points of intersection, but we'll put some meaning to it as well with like real world problems. Okay? All right. And then we're going to be done with our conics. That's the last thing we have to do. All right, so pencils down. The first thing I'm going to ask myself is, are x and y both squared? Are x and y both squared? Yes. So we know it's not a parabola. Do x squared and y squared have the same sign? Positive x squared, positive y squared. They have the same sign, so it's not a hyperbola. Next I ask myself, do x squared and y squared have the same coefficient? Coefficient of 4, coefficient of 1. Do they have the same coefficients? No, they do not. So it can't be a circle. It must be an ellipse. So I'm just keeping that in the back of my head as I do this one. So I'm going to start with this, and you guys are just going to watch what I do. Then I'm going to do another one. You're going to watch what I do, and then we're going to talk about it. Okay. So what I want to do is I want to gather my x's first. There's that one. Minus 40x. There's that one. I'm going to complete the square with this. I'm just going to keep it here right now. Then I've got plus y squared minus 6y, and I'm going to put the 93 on the other side. Negative 93. My next step is I've got to pull that 4 out of there because I can't complete the square with it in there. So pull the 4 out, and I have x squared minus 10x. I'm going to make this a perfect square. I'm going to put my little box in there. I think I'll wait to put my box on the other side. This one I don't have a coefficient, so I don't have to worry about it. So this is going to be y squared minus 6y plus something. That's going to be a perfect square. And on the other side, I'm going to have my negative 93. I'm also going to have whatever I completed the square with of my x's and whatever I completed the square with my y's. Only with my x's, I don't have one box, I have 4 of them. 4 boxes. Then from what you guys knew from last unit, in order to complete this square right here, oops, my prettiness, what number would I have to make this in order to make this a perfect square trinomial? It'd have to be, well, we could technically say negative 5 squared, right? Because I cut 10 in half, which is 5, and I square it, 5 squared. So over here must also be 25. Where are we at? Now, I look and see what's going to make this a perfect square trinomial. I look at it and say to myself, if I cut the 6 in half, I have 3. Negative 3 squared is going to make me 9. So now I just have to put all the pieces together. This is going to be 4 perfect squares that have x minus 5 squared. Remember, this number comes right back here, plus the perfect square of y minus 3 squared equals all of this put together, which is 100, minus 93 plus 9, which is 16. In order to put this into standard form, I want a 1 here, so I'm going to divide everybody. Let's do that in red. Divide everybody by 16, everybody by 16, everybody by 16, which leaves me with a standard equation of, these are going to cancel, would leave me with a 4 down here. So I'm left with x minus 5 squared over 4 plus y minus 3 squared over 16 equals 1. So basically I'm just completing the square twice. Gives me this, which is really easy to graph. I know my center is going to be at 5, 3. So we're at 1, 2, 3, 4, 5. 1, 2, 3. On the x-axis, that's really 2 squared. I'm going to go out 2 and 2. And on my y-axis, I'm going to go out 4, which is 1, 2, 3, 4. 1, 2, 3, 4. And there's my conic, which is an ellipse because it's plus. If it was minus, my branches would go out. Do one more and then have you guys copy it down? Okay, go through the process one more time. So I'm going to ask myself, are both x and y squared? X is squared, y is squared, yes, so it's not a parabola. Do x squared and y squared have the same sign? X is positive, y is negative. They do not have the same sign, therefore it's a hyperbola. You should be able to look at these and tell me what it is just by looking at it. All right, so now I'm going to get to work. And I say to myself, I've got a 16x squared. Get rid of that. I've got a negative 64x. I've got negative 9y squared a negative 18y, and a positive 89 when I put it on the other side. And I will argue with you after I finish completing the square, this number is going to be 144. And I can tell just by looking at this right here. And I challenge you at the very end to tell me how I knew it was going to be 144 just by looking at my equation. Okay. So 16, if I pull a 16 out, I'd be left with x squared minus 4x plus something minus 9, well, out of 9, y squared minus 2y plus something equals 89, but I'm going to have to add to that 89. Not only do I have a box there, but I have 16 of them. So 16 boxes of something, and I also have negative 9 boxes of something. This is the hardest part. You have to remember that negative 9 piece, right? It's not just positive 9 of them, I've got negative 9 of them. Lastly, figure out what I'm going to put in these boxes. Well, if I cut 4 in half, that's 2, so it's negative 2 squared. A negative 2 squared is a 4. Cut 2 in half, that's 1. Negative 1 squared is a positive 1. So now I have 16 x minus 2 squared minus 9, change my color, minus 9 times y minus 1 squared. And what did I say this was going to equal again? Does it equal 144? Okay, last thing I have to do, divide everybody by 144. Divide everybody by 144. Divide everybody by 144. I am left with the 16 and the 144 cancel each other out, and it leaves me with a 9. I know that because of what I was saying earlier. I was doing the math in my head. 9 and 144. If I cancel a 9 from a 144, I get 16. So this is y minus 1 squared over 16 equals 1. Give you a second to try and figure out how I knew what it was going to be from the very beginning. While you guys copy this one down. Alrighty, so I'm going to go ahead and graph this one for you. Uh-oh, where'd it go? Oh, it's down here. Alright, so I'm going to ask myself what my center is. We'll stay consistent in our color. So my center is 2, positive 2, negative 1, positive 2, negative 1, positive 2, negative 1. We started with blue with the x's. Okay, so if this is my horizontal change squared, then it would be 3 squared, which means I go out 3, 1, 2, 3, and out 3, 1, 2, 3. And this one would be 4 squared. So I'm going to go up 4 and down 4. 1, 2, 3, 4. 1, 2, 3, 4. Here's my slope box because it's a hyperbola. That gives me my boundaries for my asymptotes. When you're sketching, you really don't need asymptotes, but we're going to draw them because we just like them. They're our friends. It's just like when you're playing pool, chalk is your friend, right? Okay, and my branches, since it's x who comes first, my branches are going to be horizontal. Look how pretty that is. Okay, moving on to number 4. All right, number 4, identify the type of conic. Can you tell me what type of conic it is? You should be able to tell me really quick. It's a parabola because x and y are both squared. No, so it's a parabola. Okay. He's up here. It's a parabola. All right, so I've got my y squared. I've got a 6y. Then I've got a 2x. And a 7 equals to 0. I need the squares on one side and what's not squared on the other side, right? So since the y is squared, it's going to have to go on the other side. So I'm going to leave my 2x, my 7 equals, put my y stuff on the other side, y squared plus 6y. I'm going to complete the square. So I'm going to have something squared. I better add that on this side too, right? Plus something. Start over. Let's see. I cut 6 in half. I get 3. 3 squared is 9. Now I'll just keep going. On this side I have 2x. Positive 9 and positive 7 is positive 16. Equals. On this side, it's going to be a perfect square. You know what I forgot? What did I forget? I messed up somewhere. Can anybody catch it? This should be negative. Right? Couldn't I, at this point, just put the negative on the outside of it? Is that okay? Because technically it means everything in there has a negative, right? Okay, so I put a negative on the outside. So we're still okay? All right, so this is going to be y plus 3 squared, but it needs to have a negative on the outside. Right? We're still okay? All right, now let's finish it up. So all I have to do is pull out a 2 plus 8 equals, I'm not going to write the negative because where am I going to put the negative? If I divide both sides by -1 or multiply both sides by -1, I really want my negative over here because it tells me that it's pointing down. Right? Okay, so write that one down and then we're going to graph it. And okay, so now I need to graph this bad boy. All right? So I ask myself, where is, I'm not going to call it a center this time though, I'm going to call it a vertex. So my vertex is my x value is right here, which is 1, and my y value is -3. So I go to 1, -1, 2, 3. Oh, you're right. This should be an 8. Good job. Okay. So this is an 8. Guys, I know that you're anxious, but I need you to calm down. Okay, I need to make sure that I didn't do something wrong. 16. The 7. You know what I must have done wrong on the other one? I must have made this a -9. Because if it was -9, it would have been 2, and that's how I got the 1. So I see what I did wrong. Okay, this is a positive 8, which makes this one a -8. Okay, the talking needs to stop. Thank you. Because I can hear it's unrelated. All right, so I have a -8, -3. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. So on the answer key that's going to be online, it's going to be wrong. This is right. Okay. Now I've got an LLR of 2. Means if I cut that in half, it's 1. Nope. P equals half of that, which is a half. So, but we're y squared, right? So it means we're either going this way or this way. It's negative, so we're going to the left. So I'm going to count out a half, and out a half, and out a 1, and out a 1, for a total of a 2. That's my LLR. I put it in the wrong spot. From the focus, I'm going to go out 1. See why I want to do the hardest one with you? Out 1, out 1. Let's change the color. And get to our closure. No! I wanted my closure. Okay. How is the equation of a circle similar to an ellipse? The equation. They're both what? They're both squared, and they both have a positive sign. What is different about a hyperbola? Has a negative sign, and there's your closure. Thanks, guys.